Hi, I'm Scott Campbell with Solve 3D.
And I'm Kevin Miller at Solve 3D.
Kevin, we just added a new feature into our object identification classification, and it has to do with classification score. Can you fill me in on what we've done here, what we've added?
Sure. So this new feature works on both panoramic images and aerial images. But what I've done here in this example with our traffic lights, as we've previously shown, when I ran the classification, the detection side, I purposely left my classification score very low at zero point 0.5, and I selected my model and ran it, and I got some results, traffic lights. And you see here I got 584 results. If I expand these results, the new feature that we added here was this new number that appears beside each of the labels. So this is the classification score for this particular label that the machine detected and calculated when it was running the detection. And you can see here that it's 0.999% confident that this is a traffic light.
So it's pretty sure that that one is a traffic light.
Right, and as a user, I can click on each of these labels and start looking at them and go, yeah, this is a traffic light. This is a traffic light. Whatever you can look at, you can see this one here. There's a one around a sign here. Probably not a traffic light. So this might be a good option here to look at this particular label. I can always right-click on it and find it in the list, and you can see here. It's label 11. It's highlighted with this exclamation mark. It's only 0.666, or basically
Confident. Yeah.
0.6% confident that that's a traffic light.
Yeah.
So what can you do with these results? A couple things. So there's a sort by classification score button here. If I click that, I can now set the filter on the lower range of where I want to cut them off or cut off the label. So I can see that 0.6 might not be very good. Um, let's try another value like 0.7. And I'm going to sort by low to high just so I can see them here. Hit submit. If I go scroll to the top, we can look at one of these 0.7s and go,
Yeah.
nope, this is
It's
still
not
not
a
traffic
still
lights.
not a traffic light. So point
Yeah,
0.7 is not what we're looking for.
yeah, some other road signs, a tree.
Tree.
Yeah, so not very useful here. So maybe we want to go even higher. And in the previous video, I mentioned that these do a pretty good job at pretty high values, but again, it depends on your objects that you're trying to find. But I'll go all the way up to 0.97 here. Your use case might be different when you try this. So let's just look at a couple of these. Yeah, here we're at a traffic light. Again, not quite sure here.
Yeah.
So
So
this is a
that's
good tool, for kind of filtering and looking at your results, and maybe try to fine tune the results to get what you need.
Yeah. So this is a good example here of what we mean by a false positive. So the model has identified this as a possible probable traffic light, and yet we as humans can clearly see that it's a traffic sign, even though it has a score of 0.972. So this is a good example of a false positive. Now, in the previous view that you just showed with the traffic lights, there was a couple of traffic lights not circled. That's a good example of what we call a
Mhm.
false negative. So it's saying that this one that's not circled, the two of them there, in fact, no, they're not traffic lights. So that's what we would call a false negative. Now, in this case, depending on your use case, we're at 0.9, what was it, 0.95? I think you had
Line
picked
7, yeah.
0.97. So this would say that depending on your use case, 0.97 or 0.98 may be where you want to be for this particular model. Or it could be that it's telling you that you need to go back and supplement your model with more training in order for it to pick up more of these traffic lights that it's not picking up now and reject more of the road signs that it's currently accepting.
That's right. And just to add to that, it's not really the end of the world that it's missed a few. It may be that if I switch to a different image, or maybe I get a little closer, it may have found it in another panoramic. So it's not the end of the world that it didn't find it, but I agree. If you can afford to do it and do a bit more training and maybe identify a few more labels just to give it a few more tips and hints on how to identify a traffic light, that might be an option to refine that model to make it even more accurate.
Okay, now, how does using this filter affect my exports?
Uh, Good question. So once you've filtered these down, so I went from 584 down to 269 in this case. If I do my export of my export labels or the export label positions, both of those will export only what is being shown here in the filter. So if you've cut it down to half the size of your initial results, you're only going to get those filtered results into your export.
Okay, so to wrap things up here for you, this filter works with both the aerial and the panoramic identification tools, even though we just showed it in the panoramic view here today. You can start with a lower classification score when you run your model, and then use this function to filter up to get the results that you want. You can also use this filtering tool to check for the score value to see where you're comfortable with the number of false positives and the number of false negatives. And then you can decide if you need to do more training or not.